Hello! Today we're going to be finishing off where we left off in section 4.4 yesterday. Yesterday we were talking about how a linear equation has two intercepts, the x-intercept and the y-intercept. Those 2 points are where your line crosses the x and the y-axis. For example, yesterday we said that the y-intercept is the point where your graph crosses the y-axis. Similarly, the x-intercept is the point where your graph crosses the x-axis. To find each of these intercepts, we would like the other variable to equal 0. If x equals 0, that's going to give us a point that is on the y-axis. So if we're looking here at the y-intercept, if x is equal to 0, that means that your point is going to lie on that y-axis. We're not moving horizontally at all. We're not moving to the left or the right at all. We're just going straight up or straight down, so your x value would be 0. Similarly, if you want the x-intercept, we're going to let the y value be 0. If the y value is 0, that means we're not moving vertically at all. We're not moving up or down. We're strictly moving left or right along the x-axis. So to find your intercepts, whether you want x or y, you're going to allow the other variable to equal 0. From there, we then moved on to talk about slope-intercept form of an equation. Slope-intercept form is y equals mx plus b. We know that m always represents your slope, so the new thing that we introduced here is that b is your y-intercept. If your x value is 0, what happens is that this mx portion of your equation becomes 0 and simply goes away. So when x is equal to 0, what we end up with is the y value equaling b. So that means the coordinate 0, b is going to lie on your graph, making b the y-intercept of your graph. From there, we went on to talk about slope-intercept form and simply identify the slope and the y-intercept of a few of these equations. In letter A, we have y equals negative 4x minus 2. We rewrote that to y equals negative 4x plus negative 2. From here, we can identify m as negative 4 and b as negative 2. Similarly, in letter B, we did the same thing, but first we have to get y by itself. So in order to do that, we added 5 to both sides. After adding 5 to both sides, y was then isolated, and we can identify the m, which is 3 over 2, and the b, which is positive 5. If you haven't already, go ahead and take a moment to try finding the slope and the y-intercept of numbers 1 and 2. For number 1, we should have m equals 3. If I change this to plus negative 7, we see that b would equal negative 7. So you have a slope of 3 and a y-intercept of negative 7. Number 2, we first need to add 1 to both sides of our equation. That's going to get us to y equals negative 2/3 times x plus 1. And now that y is isolated, we can see the m value in front of the x. So m would equal negative 2/3, and b would equal 1. In example 2, we're going to graph and we're going to identify the x-intercept. In order to graph it, I'm going to do it 2 ways. The first way I'm going to do it is just to develop a chart. I have my x and my y. We can pick whatever numbers we want. We can pick x values or we can pick y values. It doesn't matter. They do ask us to find the x-intercept here. To find the x-intercept, that means that y equals 0. So the first point I'm going to have in my chart is the one where y equals 0. I still need to do a little bit of work to find x, but I can start with y equaling 0. From there, we can really pick whatever we want. And since x's usually are a little bit less work, I'm going to go ahead and pick a few x values. I'll go ahead and pick 1, I will pick negative 1, and I will pick 2. These can be whatever values you'd like. I just think that they give us a good range of numbers for our graph. So now to complete the chart, I'm going to go ahead and let y equal 0 and determine what the x value is that corresponds with that. Solving for x, I'm going to go ahead and subtract 3 from both sides. I have negative 3 is equal to negative 3x. Dividing by negative 3, I find that x has to equal 1. So when y is 0, x is 1. Now my next x value, x is 1. Well, we just did that. The y value that goes with 1 is going to be 0. I'm not going to go through that work a second time. When x is negative 1, I'll plug that in. Y equals negative 3 times negative 1 plus 3. So y is equal to positive 3 plus 3, which means that y is equal to 6. So when x is negative 1, y is equal to 6. Lastly, I'll plug in the 2 for x. Y equals negative 3 times 2 plus 3. So y equals negative 6 plus 3, which leads us to y equals negative 3. So when x is 2, we have a y value of negative 3. I have a few points, so I'm going to go ahead and go over to my graph and plot these points on my coordinate plane. I have 1 for x, 0 for y. That's on the x-axis, so that's my x-intercept. My next point is negative 1 for x and 6 for y, so I go left to negative 1 and then up 6. So 1, 2, 3, 4, 5, 6 would be here. And then my last point is the coordinate 2, negative 3. So 2 down 3 would put me here. Connecting these dots, my line looks something like this. Now just to double check, we're going to go ahead and verify our y-intercept and our slope. Counting my slope on my graph, I'm going to go ahead and go from my x-intercept to the point below it. I'm going to go down 1, 2, 3, which means the numerator of my fraction for slope is going to be negative 3. And I go over 1, which gives me a slope of negative 3. If we look back to our equation, we see that m is in fact negative 3. Now let's double check the y-intercept. We're interested in where the graph crosses the y-axis. Now the graph isn't exactly straight, but if we did straighten this out a little bit, you would see that the graph crosses at y is 3. Or another thing we can do is simply count our slope again. Our slope, if I'm moving from the bottom of the graph up the line, would be left 1, up 3. So I'm going to go ahead and copy that slope again, left 1, up 1, 2, 3. The graph would actually cross here. And you can continue to double check that slope, left 1, up 1, 2, 3. So all of those blue points are in fact on our line. Whether the line is straightly drawn or not, those blue points should lie on the line. So that means that this point here is our y-intercept. So b, the y-intercept, should equal 3. And if we look back to our equation, we do in fact have that b value equaling 3. On this next slide, we're going to go ahead and take a slight shortcut in graphing. Instead of creating a table, we are going to graph it using the slope and the y-intercept. So in this example, we read that the cost y in dollars of taking a taxi x miles is y equals 2.5x plus 2. Now to interpret kind of what the equation is saying, we've got y being how much money the taxi costs. So the amount of money that this taxi costs equals 2.5 times x, and x is your miles, plus 2. So how I interpret this is it's going to cost you $2 just to get in the taxi. Once you sit in the taxi, that costs you $2. Then the taxi driver is going to charge you $2.5 for every mile that you go. So you only pay that initial $2 one time, and then after that, we're adding $2.50 every mile that you travel. We're going to go ahead and graph this equation, and then interpret the y-intercept and the slope of the equation. So first thing I'm going to do is look at my equation, y equals 2.5x plus 2, and notice that this is already in slope-intercept form, where y equals m times x plus b. So that means if I'm comparing the coefficients to my variables, that means that m would have to equal 2.5, and that means that b has to equal 2. Now, slope being 2.5 is a little bit difficult to graph. So what I'm going to do is I'm going to say this is 2.5 over 1. And the reason I say that that is difficult to graph is because that means you're going up 2.5 units and over 1 unit. But that's a little bit imprecise. So what I'm going to do instead is I'm going to make sure that I do not have a decimal in my fraction. To do that, I could multiply by 10. Multiplying by 10 would take the decimal and move it to the right one time. But instead, I can multiply the numerator and the denominator by 2. And that's going to give me a slope of 5 over 2, which is just a little bit easier to work with. It's the same thing as 2.5, just a little bit easier to graph. So now I'm going to take the slope and the y-intercept and use only those two things to graph my equation. Starting at a y-intercept of 2, that means I'm going to start on my y-axis at the point where y equals 2. We can consider this b value as the coordinate 0, 2. So I just plotted that on my graph. Now from here, we know the slope is 5 over 2. We just don't have a line to verify it. But we do know the slope. So what we're going to do is start at the point that we have on our graph and count the slope up 5 over 2. So from my y-intercept, I know that my line has a slope of 5 over 2, which means my next point will be up 5, 1, 2, 3, 4, 5, to the right 2. So my next point would be there. Now I can't go up 5 and over another 2 because I would be off my graph, but what I could do is say that m equaling 5 over 2 is actually the same thing as equaling negative 5 over negative 2. So that means I can start at my blue point and go down 5, 1, 2, 3, 4, 5, and to the left 2. And as you can see, those 3 points are in fact all in a line. So instead of creating a chart like we did for the last question where x and y are values that we select, we can instead plot our b value on the graph and then count our slope from there. If you would like to verify, let's go ahead and pick an x value. Let's say that x is 2. I picked this value specifically because I don't want any decimals in my answer, but you could pick anything you want. So y equals 2.5 times x plus 2, but we know that my x value is 2. So y equals, this becomes 5 plus 2, which means y equals 7 when x is 2. Let's just verify that my line is accurate by going to the point 2, 7. If it's on the graph, then we have done this correctly. I go to the right 2, up 1, 2, 3, 4, 5, 6, 7, and it is in fact a point on my line. Go ahead and take a moment to pause the video and try these next two on your own. Try using the slope and y-intercept form that we just did, but then check it with a point or two of your choosing. In number 3, you should have a slope of 1. The invisible coefficient here on x is 1, so my slope is 1. And if I change this to plus, I would have plus negative 4, meaning my b value is negative 4, or my y-intercept is the point 0, negative 4. So on my graph, I plot my b value, and then from there, I need to graph my slope. Slope is a fraction with a denominator of 1, since there's no denominator explicitly shown. So from my y-intercept, I count up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and my graph looks something like this when I am done. You can double check with a little quick chart. Pick any x value you want. Maybe I pick the x value of 3. So y is equal to 3 minus 4, which means y is equal to negative 1. Double checking on my graph, the point 3, negative 1 is in fact a point on my line. Similarly, for number 2, we plot our b value of 1 and then count our slope of -1/2 to get the line shown. Thanks so much for watching. I hope you enjoy the rest of your day.